Have you ever wondered where it all began? Where we came from? What birthed the cosmos and all that we know? Let's take a step back, some 14 billion years ago. Picture an infinitesimally small point, brimming with immense heat and density. This is the singularity, the origin of everything. The stage was set for a cosmic event of unimaginable proportion, the Big Bang. From this singularity, everything that we see, feel, and experience in the universe sprung into existence. In the very first moments after the Big Bang, the universe was a hot, dense soup of particles. As it expanded, it cooled. Particles coalesced, forming atoms. Over billions of years, these atoms clustered together into the galaxies, stars, and planets. So, from a point of nearly infinite density, the universe has grown, evolved, and shaped itself into the vast cosmic expanse that we're still exploring today. From an infinitesimally small singularity, the universe has expanded into the vast cosmos we explore today. As the universe cooled and expanded, matter began to form and coalesce. This was the beginning of a process that would lead to the formation of galaxies, those colossal collections of stars, dust, and gas that populate our universe. Imagine the universe as a giant cosmic stew, simmering away for around 300,000 years after the Big Bang. As the universe expanded, it cooled, and its ingredients, particles of matter, began to clump together. This clumping was facilitated by an invisible and mysterious substance known as dark matter. Despite its elusive nature, dark matter plays an integral part in our universe's story, its gravitational pull acting like a cosmic glue, helping to bind matter together. As these clumps of matter grew larger, they started to collapse under their own gravity, forming the first galaxies. These early galaxies were likely quite small, filled with young, hot stars. Over time, these galaxies collided and merged, growing larger and more complex, eventually forming the vast galaxies we see today. And within these galaxies, billions of stars. Each star, a gigantic nuclear furnace, churning out light and heat, bathing their galaxy in a warm, cosmic glow. But it's not just stars that make up galaxies. There's also a vast amount of dust and gas, the raw materials for new stars. This interstellar medium fills the space between the stars, bound together by the same force that holds the stars in place, gravity. But galaxies are not evenly distributed throughout the universe. Instead, they form a vast cosmic web, with galaxies clustering together in groups and superclusters, separated by immense voids of empty space. This cosmic web, spanning the entire universe, is a testament to the power of gravity and the role it has played in shaping the universe. So next time you gaze up at the night sky, remember that each point of light is part of a galaxy, a complex system of billions of stars, bound together by gravity, all part of the grand cosmic web. These galaxies, each with billions of stars, form the cosmic web that makes up our universe. In the heart of these galaxies, stars are born and die, each playing a crucial role in the cosmic drama. Like the actors in a grand play, each star has its unique story, its life cycle. It all begins in a nebula, a vast cloud of gas and dust. Within these cosmic nurseries, gravity pulls matter together into a dense core. As this core accumulates more and more material, it heats up, and when it gets hot enough, nuclear fusion ignites. A star is born. This star now enters its main sequence, the longest stage of its life, where it steadily burns hydrogen in its core, converting it into helium. This process releases a tremendous amount of energy, lighting up the star and causing it to shine brightly in the night sky. But even stars cannot escape the inevitable march of time. As they exhaust their hydrogen fuel, they start burning heavier elements, leading to their eventual demise. The death of a star is as spectacular as its birth. Depending on its mass, a star may end its life as a white dwarf, a neutron star, or a black hole. A white dwarf is the remnant of a medium-sized star like our Sun. It's essentially the star's core, left to cool and fade over billions of years. A neutron star, on the other hand, is the compressed core of a larger star, so dense that a teaspoonful would weigh as much as a mountain. And then there are black holes, the remnants of the most massive stars. Their gravity is so strong that nothing, not even light, can escape. But here's the fascinating part. The death of stars leads to the creation of heavier elements. Each time a star dies, it scatters these elements into space. These cosmic seeds then find their way into new stars, planets, and even life forms. So in a way, we're all made of stardust. In the fiery crucibles of stars, the elements that make up our world and our bodies are forged. At the end of their lives, massive stars collapse into themselves, forming what we know as black holes. These celestial entities, black holes, are regions in space where gravity pulls so much that nothing can escape from its grasp. Not even light, the fastest known entity in the universe. It's like a cosmic trapdoor from which there's no return. This intense gravitational pull is the result of matter being squeezed into a tiny space. Imagine squishing Earth to the size of a peanut while maintaining its mass. The gravitational pull would be so strong, you'd need to travel at the speed of light to escape from it. That's how black holes work, and it's just one of the many reasons they're one of the most intriguing phenomena in the cosmos. Black holes aren't just fascinating, they're also pivotal players in the grand cosmic theater. They can influence the paths of nearby celestial bodies, warp the fabric of space-time, and even manipulate the growth of galaxies. In fact, at the heart of every galaxy, including our own Milky Way, lurks a supermassive black hole, millions to billions of times the mass of our Sun. While black holes are invisible to the naked eye, scientists have found ingenious ways to detect them. They observe the effects of their gravity on nearby stars and gas. When a star gets too close to a black hole, high-energy light is made. This light cannot be seen with human eyes, but can be detected by telescopes in space. But the enigma of black holes extends beyond their gravity. They're also believed to be the key to understanding the fundamental laws of physics, potentially bridging the gap between quantum mechanics and general relativity. In this way, black holes aren't just cosmic phenomena, they're gateways to a deeper understanding of the universe. Black holes, these enigmatic titans of the cosmos, continue to be a source of fascination and mystery. The more we learn about them, the more questions they pose, reinforcing the notion that our universe is a vast place of untold wonders waiting to be discovered. From the Big Bang to the formation of galaxies and stars, we've journeyed across billions of years to the universe as we know it today. A vast expanse of space, filled with clusters of galaxies, each with countless stars, and possibly a multitude of planets just like ours. Currently, we find ourselves residing in an ever-expanding universe. That's right. The universe is not static, but is in fact growing larger every second. This expansion is a direct result of the Big Bang, a force so powerful that it set the universe into motion, and that motion continues even now, billions of years later. But what does the future hold for our universe? Well, there are several theories that scientists are exploring. One of these is the concept of the heat death. This theory suggests that as the universe expands, it will eventually reach a state of maximum entropy. In simpler terms, everything will become uniformly spread out, and the energy required for star formation will no longer exist. The universe, in essence, will become a dark, cold, and lifeless place. On the other end of the spectrum is the Big Crunch theory. This proposes that the expansion of the universe will eventually slow down and stop. Then, gravity will take over, pulling everything back to a singular point, potentially leading to another Big Bang and the birth of a new universe. These theories may seem daunting or even scary, but it's important to remember that these events, if they occur, are billions of years in the future. For now, the universe continues to be a place of wonder and discovery, a cosmic ocean teeming with mysteries waiting to be unraveled. As we gaze upon the stars, we are looking into the past, witnessing the story of the universe unfold before our very eyes. The universe, with its galaxies, stars, and black holes, is a testament to the incredible journey that began with a single, explosive moment. From the Big Bang, the universe burst into existence, unfolding in a fiery dance of particles and energy. Out of this cosmic maelstrom, galaxies were born, spiraling clusters of stars that light up the cosmos. Stars themselves, cosmic furnaces of nuclear fusion, were born, lived and died, sometimes collapsing into the enigmatic abyss of a black hole. These celestial phenomena, both awe-inspiring and terrifying, are the universe's most enduring mysteries. And yet, the story doesn't end there. The universe continues to evolve, to change, to expand. Its future, like its past, is written in the stars, in the galaxies, in the black holes. Wherever our journey takes us, the universe, in all its majesty and mystery, will continue to captivate and inspire us.